I will be working out question number 2 in exercise 9C. So, question number 2 gives us an arithmetic sequence with the first 4 terms, the terms 6, 10, 14, and 18. And if you forgot what arithmetic sequences are, these are sequences that are produced by adding a specific number every time. Show that the sum to n terms can be written as 2n squared plus 4n. If the sum to n terms is 880, write a quadratic equation to represent this information. Rearrange to equal 0 and plot a graph of this equation on your GDC, so on your calculator. Hence, sketch the graph on paper showing the coordinates of the vertex and axes of symmetry, axes intercepts. Find the positive x-intercept. State what information the positive x-intercept tells you about the sequence. So, I've written a few notes down that we need to know in order to solve this. First off, we need to find the sum to n terms, and we need it to equal 2n squared plus 4n. So we need to prove that this is the sum to n terms. So a couple equations I wrote down. This is the sum from 1 to the n term. So it'd be n over 2 times u1, which this is the first term of the sequence, plus un, so this would be the last term of the sequence. And in our case, un, we don't know what n is because it's to the nth term, it's not to a specific term. So what we then need to also use is this formula, which this is the formula for finding the nth term. And this is the nth term is equal to the first term plus n minus 1 times d. d is the common difference. So that is the number that when you add or subtract, it takes you to the next number in this sequence. So what you may notice is to go from 6 to 10, 10 to 14, and 14 to 18, that is adding 4 or increasing by 4 every time. So we know that the common difference is 4 for this specific sequence. We also know the first term listed, which is 6, so that means u1 is equal to 6. So now I am going to use substitution, and I am going to use this sum, and in place of un, I'm going to use this formula for the first term and the nth term and the common difference, since I don't know what un is. And I don't want two unknowns. N is already unknown, so I also don't want a un unknown as well. So we have n over 2, and then multiplied by the first term, which is 6, plus the nth term, which instead of un, I'm going to use this formula for un. So I'm going to put the first term plus n minus 1 times d. So u1 is 6, plus n minus 1 times the common difference, which is 4. And this is the sum to the nth term. Now I'm going to simplify this whole thing. So 6 plus 6 is 12. When you distribute the 4 to the n and the minus 1, you get a 4n minus 4. So I have 6 plus 6 is 12, and 12 minus 4 is 8. So that simplifies to 8. N times 4 is 4n. And on the outside, I still have the n over 2. So I just simplified this inside part. Now I'm going to distribute the n over 2 to the 8 and also to the 4n. So n over 2 times 8 is 8n over 2, which can simplify to 4n. And n over 2 times 4n is 4n squared over 2, which can simplify to 2n squared. So if you notice, the result we got proves what we were trying to prove, that the sum to the nth term is 2n squared plus 4n. So if I want to, I could reverse the order of this and write it as 2n squared plus 4n, but you can see that those are equivalent, those are equal. So that's part A. Part B now, we need to prove that if the sum of this sequence is 880, we need to find the vertex, the axes intercepts. And so I'm going to make sure to use this formula, which this is the finding the axis of symmetry formula, negative b over 2a, and this is from quadratic equation. So quadratic equation in standard form would be ax squared plus bx plus c equals 0. So when I'm using negative b over 2a, what I mean is the negative b terms of the term in front of x over 2 times the a term, the term in front of x squared. And that would tell me the x value for the axis of symmetry, which is the vertex point. So I would then have to use substitution. Whatever I get for x, I would substitute it into the quadratic equation formula to then get the y value for the vertex. So what I'm going to do first is I'm going to write this as a quadratic equation, and I'm going to use this 4n plus 2n squared, and they said that if that sum is equal to 880. So I'm going to write it as 2n squared plus 4n is equal to 880. I'm going to write this in the quadratic standard form, so I need it to equal 0, which means I need to take this 880 and move it to the left side by subtraction. So I get 2n squared plus 4n minus 880 equals 0. From here, I could use my calculator and find the x-intercepts, or I could use the quadratic formula to do this. So I'm going to show this with the quadratic formula. If you remember the quadratic formula, it's x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to replace the b, the a, and the c with the a, b, and c in the quadratic equation written here. So a is 2, b is 4, and c is negative 880. So when I substitute that into the quadratic formula, I have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 880 all over 2 times 2. I'm going to simplify this. You could type all this into your calculator. Just make sure that this is all in the numerator with brackets around the first and the end of it, and then divide all of it by 2 times 2. Divide all of it by 4. You will get 2 answers. One of your answers will be positive 20. The other will be negative 22, and that is because of this plus or minus. So one answer is when you add the value of the square root, and one answer is when you subtract the value of the square root. So now that I have these 2 answers, that means my x-intercepts are at 20, 0, and negative 22, 0. And I know y is 0 for both of those because I set it equal to 0. And the quadratic equation would be written as y equals 2n squared plus 4n minus 880. So when I say n, what that really means is that's the x-intercept. You could write it as x, so 2x squared plus 4x minus 880 equals y. You could write it that way as well. So those are my x-intercepts, so that's where it crosses the x-axis at those 2 points. Now to find the vertex, or the axis of symmetry, I'm going to use that formula right here. I'm going to substitute in place of b and a, I'm going to substitute 4 and 2. So I have negative b, which is negative 4, over 2a, 2 times a, 2 times 2. And that gives me negative 4 over 4, which if you simplify that, that is negative 1. So that means the axis of symmetry is at x equals negative 1. So to find the vertex, I need to take negative 1 and replace it or substitute it into the quadratic equation to solve for y. So again, that quadratic equation is y equals, we're going to write this as 2x squared plus 4x minus 880. Okay, in place of x, I'm going to use my axis of symmetry, which is negative 1. So I'm going to write this as y equals 2 times negative 1 squared plus 4 times negative 1 minus 880. Sorry, that's poorly written down there. So I get y equals negative 1 squared is 1, so 2 times 1, 2, plus negative 4. So that would be negative 2 minus 880 would be negative 882. So your vertex is at negative 1, negative 882. That's your vertex. So we have the vertex, we have the x-intercepts. So if you want to graph this, I'm just going to write in place of y equals. I'll zoom in on this. So I'm going to write the equation, which was 2x squared plus 4x minus 880. I'm going to graph that. You're not able to see it, so I'm going to change the window. I'm going to go to zoom. Once this is ready, go to zoom. I'm going to go to fit. You can kind of see the graph here. It might be easier to see it if you were to change the windows, zoom out a bit. So if I change the windows and I zoom out a bit, I go to window. I'm going to change the x minimum. I know it at least goes to negative 22 because that's the x-intercept. So I'm going to go to negative 30 for the x-min. For the x-maximum, I'm going to go to, I know the x-max is 20. So let's say 25 for the x-max. We'll go by 5s for the scale. The y-minimum, let's say negative 10. Y-maximum, let's go up to, y-minimum, we have at least negative 882 because that's part of the vertex. So let's make the y-minimum negative 900. We'll make the y-max 10, and we'll go by a scale of 100s. So here you can see the graph. You can see the two x-intercepts on either side, and you can see the vertex down below. So if I go to second trace, I can find the x-intercepts and I can find the vertex. So let's go to minimum because the vertex was a minimum since it opened up. And I'm going to click just to the left and the right of that spot. So you can see my clicking was not very accurate, but it shows you the x minimum, so it's about a negative 1, negative 882. And then you can see the x-intercepts if you go to the zeros and you find the x-intercepts there. So that is how you solve this exercise. The last question it asks then is just what does the information, the positive x-intercept, tell you about the sequence? And what it tells us is just the sum of the first 20 terms because the positive x was at 20. So the sum of the first 20 terms, since x or n referred to the term, so when n is 20. So the sum of the first 20 terms is 880.